Okay, so I'm going to be going through some of the answers for the types of chemical reactions practice. Okay, so here we indicate which type of chemical reaction uh, is occurring based on what we can see. Okay, whether it's a synthesis, decomposition, single displacement, double displacement, or combustion reaction. And I want you to use the table I've created and the notes to help you as you go through this practice sheet. Okay, so what I'm talking about specifically, um, you should have this projected on the screen if you're in class. If you're not in class and you're working this at home, pull this up. Okay, take a screenshot of it. Do whatever you need to. Okay, in the notes section, but this will be there to help you, right? So just as a review, synthesis, you will have, an A plus B yields AB. So this is two, either a react or in the reactants, you'll have either a compound and an element, or two elements or two compounds, and they will always make one compound. Okay, over here, but it's two plus two equals one over here. Decomposition is exactly the opposite. You have a compound which is broken down into two. Single displacement, again, we have, let's say, the example of two metals, A and B, and a nonmetal X. Those two metals will switch places to be AX plus B. And then we have um, a metal with two nonmetals, right? And so only that metal can switch with those two nonmetals. So those two nonmetals are going to switch places. And so we'll have AY plus X. Double displacement, okay, we'll have the metal, the two metals will switch places. And so instead of being AY plus BX, we'll have AX plus BY. And then on hydrocarbons, very important here, okay, um, CH or CHO will be right here. That doesn't matter, but what will always be the same is you'll have you'll have the O2, the CO2, and and the H2O. Okay, so these three will always be the same. You'll always have those. This number may vary, or this binary part of the compound may the equation may vary, but these will always be the same. So you'll have that in front of you, okay, as you go through. And I'll use some of the language as we go through here, okay? And so we have Na3PO4 plus 3KOH and 3NaOH plus 3 K3PO4. Okay, so forget about balancing all this stuff out. All we're worried about now is what's going on. Okay, we have a compound here. Okay, so I want you to identify, do we have an element or a compound? We have a compound here. Is this an element or a compound? This is a compound. Okay, so there's two compounds on this side of the equation. What do we have on this side? An element or a compound? It's a compound. Okay, now why is it a compound? Why is it not just an element? An element is single, right? So an element is just, I could say sodium is an element. Okay, oxygen is an element. Hydrogen is an element. But sodium hydroxide, that's what this is a compound. Okay, this one. So this is a compound. What about this one? KPO4. Okay, this is also a compound. So if we have two compounds yielding two compounds, and we take a look, which do these look the most like? Well, it doesn't look like this one or this one, right? AB plus, oh no, that's a compound there, and these are, okay. Does it look like we have, okay, an element and a compound yield? Nope. Okay, what about a compound here and a compound here? Yield a compound here and a compound here. Okay, that's what it's going to be. We're going to have a double, actually we'll just put DD. That's all I need. Double displacement. Okay, double displacement reaction. So next one. Okay, I'm only going to do a few here to give you an idea of what to do. Then you're going to finish the rest. Okay, and then you're going to go through the answers together. Okay, so then let's skip number 2. Okay, we'll come back to that another time. C6H12 plus 9 O2s yields or produces 6 CO2s and 6 H2Os. Okay, what did I say about, let's see here. There is a compound here, and this is an element here, because all we have is one. Okay, we just have oxygen, right? But then we have a compound here and a compound here. So this is getting a little messy. Let's go take a look at our sheet here. Okay, so which one of these does it look the most like? Right? Does it look, okay, so because remember the first one had a compound and an element, but then it yielded 2 compounds on the other side. So it doesn't look anything like this one. This has 2 compounds, but it has 2 compounds on that side. Remember, C6H12 plus O2 yields CO2 and H2O. Okay, so what do we have? C6H12, right? Remember, that's the CH right here. And then we have our O, our CO2, and our H2O. Okay, so this is what we call a combustion or hydrocarbon combustion reaction. Okay, always look for these 3, right? This number, this number, this number, that might change, but you'll have O2, CO2, and H2O, which are always present. Okay, Pb plus FeSO4 yields PbSO4 plus Fe. So which does this look the most like? Okay, which one of these does it look the most like? We have PbSO4, or sorry, Pb plus FeSO4 yields PbSO4 plus Fe. Okay, if you said single displacement, you were correct. Okay, so this is single displacement. Okay, this one here, got CaCO3. So this is a compound, and what's happening? It's breaking down. When it's breaking down, it's decomposing, a decomposition reaction. Okay, it's breaking down. You see that? Okay, so we call that a decomp. Okay, decomposition. Okay, let's go to number 10. We have 2C5H5 plus Fe yields Fe C5H5 to the 2. Okay, so what does this look the most like? If you were to take a look at all these, what does it look the most like? Okay, yes, remember you can have a compound and an element together, but as long as they make something on the other time, a single product on the other side, it is a synthesis reaction. So this right here is a synthesis reaction. Okay, synthesis reaction. Now, That's all I'm going to do with you here. You're going to have to figure out the rest as you go, and then you'll go through it together as a class.